this question, how we have to evaluate, we'll see first. A value is 1, A value is 1, B value is 2. So when we are coming to here, when we are coming to here, this is a pre-increment. The value 2 it is going to be get, and that is going to be assigned to C. Now it means C will be having, sorry, pre-increment, right? Here it will be becomes as 3. Then
3.
this value will be assigned for
B2.
B. Sorry,
B
B
value
value
will
is
be 2.
already we have 2. This is a pre-increment. It will becomes as 3.
Yes, sir.
So that 3 is
Yeah.
going to be assigned to C. Next,
Mm.
A post
D
increment.
value
A
2.
value is 1 here. Only 1 is going to be assigned to D. After completion of this instruction, A value will becomes as 2.
2.
After completion of this instruction, A value will becomes as 2. After this instruction. Okay. Now, see what is the C value? We have 3. Here the C value is 3.
4.
When it is moving to the next instruction, C value will becomes as 4. When we
4.
consider C value is 4. Okay.
B
Next,
value 3.
B post increment. Here it will be uh,
2.
here 3. No, already we got 3 here.
Clear.
That 3 after completion of this instruction, it will becomes as 4.
Mm.
B will be 4. And now A value already we have 2 here.
3.
Pre-increment, A value will becomes as 3.
Mm.
A value will becomes as 3. 344 is the answer for this. We'll check that.
Okay.
We'll check that. I'll take the same part of code. Got it? So 344 we got. A value is 3. A value is 3 here. B value is 4. And C value is also 4 we got. So that what we got here. That what we got here. The output of this code is this one. Okay.
Okay, sir.
So like that, you have to analyze each and every line of code. You have to analyze each and every line of code, and you have to determine what the instruction is going to give the output. What the particular
Okay,
instruction is going
sir.
to give the output. What is?
Okay, sir.
There is the output. Next topic. So in the previous class we have discussed about unary operators, and we have discussed the examples of unary operators: unary plus, unary minus, increment, decrement operators. This we have discussed in the previous class. Now we'll come to the binary operators. What are the different types of binary operators we have first? See, arithmetic operators, then assignment operators, relational operators, logical operators, bitwise operators. These are the different types of operators we have. These are the different types of operators. So first we will see about the arithmetic operators. First we will see about the arithmetic operators, which are used to perform arithmetic operations, used to perform arithmetic operations. What are the operators we have? Addition, subtraction, multiplication, division, and finally we have modulo division. See here, after dividing a with b, after dividing a with b, after dividing a with b, we'll get quotient as answer if it is a division operation. Quotient will be getting as answer after division. Whereas coming to this modular division, after dividing a by b, I mean a value is going to be divided with b, will get remainder as answer. Will get remainder as answer. We'll see that operators. New class, arithmetic operators, arithmetic operators. See, let me consider input n1 into two numbers and the result I'll be taking three variables. Total three variables I have declared with data type. Total three variables I have declared with data type int. I have to initialize the value, that is n1 is 10. I'll be initializing. N2 is 5. I'm initializing. These are static initialization of values only. We are initializing the values in the program itself. We are initializing the value in the program itself. See, result will be here we are performing the addition operation n1 plus n2, adding two numbers. See here we are seeing the red color mark. It means we missed to write the semicolon. Because of that, it is giving the error. And system.out.println, just to print the value of this, just to print the value of that result of or addition result I'll give for our understanding purpose only. I'll be taking the result, or I'll take this separate variable as, and I'll take one more separate variable for subtraction, subtraction, multiplication, division, modular division. So different variables I have declared here. For subtraction, we'll be having n1 minus n2. Subtraction. We are going to be print as subtraction result, or subtracting n2 from n1, like that also you can write. That is our wish for our, for our understanding. Multiplication n1 multiplication n2, n1 multiplication n2, multiplication result will be getting null. Division n1 divided by n2, division result m division modulo division m division we are getting. So we'll execute this now. Addition result 10 plus 5 15. Subtraction result 10 minus 5 5. Multiplication result 10 into 5 will be getting here 50. And see, division result 2, 10 divided by 5. And modulo division result, sorry, here I have taken only division operator, because of that we are getting wrong. This is nothing but logical mistake. This is nothing but logical mistake. So it is not given any error during syntax. There is compilation. During execution time also we didn't get any error, but we are getting the wrong result. That is the result, uh, not per our expectation, not as per our expectation. Because of that only we are going to be say that logical error. So based on that, have checked where we are getting wrong result. That related code I have verified. Instead of division, we have taken as modular division. Because of that, it has given that error. So just I've rectified that, and we'll see exact result we are getting. Remainder we should get 0, 10 divided by 5. And one more thing here we have to concentrate is, this is a small program. This is a small program. If we are getting mistake anywhere, we can able to identify easily. There is logical mistakes we are getting anywhere, we can able to identify it easily. But the code is bigger, some thousands lines of code we have. In that particular moment, if you want to identify that mistake, it will be difficult. For that only, we are going to be follow the debugging process. We are following the debugging process. That process we will see in the coming sessions. Mm. Next topic, series assignment operators. This is the assignment operator. This is the assignment operator. What will what will be the working of this assignment operator is x. This is the value. So the value 10 will be assigned to the variable x. The value 10 will be assigned to the variable x. See, this is the assignment operator. This is the assignment operator. Whatever may be the value we have at the right side of this assignment operator will be assigned to a variable at left side. So if we have any compound expression uh, like a plus b, the result of this is going to be assigned to a variable at left side or c. The result of this is going to be assigned to the variable at left side. See, right side we have this compound expression. After evaluating this compound expression, the result is going to be assigned to the single variable. And here as well, the value 10 is going to be assigned to a single variable. The value 10 is also assigned to a single variable. So the value can be assigned to a single variable, or after getting the compound expression, the result we can able to assign to a single variable. But we are not supposed to write like this. The variable cannot be assigned to a value x. Sorry, variable x cannot assign to value 10. Variable cannot assign to value 10. In the same way here, a plus b is c. Single variable value c cannot assign to compound expression a plus b. And we have different types of assignment operators. We'll see that different types of assignment operators. Addition assignment, subtraction assignment, multiplication assignment, division assignment, modular division assignment. See, these are the assignment operators. See, now x value we have as 5, x addition assignment to 2, 2 if we have here, x addition assignment to 2, 2 we have here. What is the x value here? How the x value is going to be evaluated? X is equals to x plus 2. Already we have the x value as 5. 5 plus 2 is going to be added here. 5 plus 2 is going to be added here. So totally it is going to give us 7. It is going to give us 7. So other operators also same. Other operators also same. See, let me consider x value is 10. X subtraction assignment to 4. What is the x value? How we are going to be get this subtraction assignment? Where we are going to be get x is equals to x minus 4. X is equals to x minus 4. X value already 10 we have. 10 minus 4 it will be 4. We'll be getting the result as 4 here. Sorry, 6. 10 minus 4 will be getting the result as 6. See, now here X additional assignment to 1, X additional assignment to 1, X is equals to X plus 1, X post increment, pre increment of X. These are all same. These are all same. X additional assignment to 1, X is equals to X plus 1, increment, X post increment, pre increment. All this is going to be perform the same task. Okay, instead of this increment, we can also write by using this assignment operator as well. Now, if you see here, the same X addition assignment to 1, sorry, subtraction assignment to 1, X is equals to X minus 1, X post increment, pre increment of X, X post increment, pre increment of X. This also works same. So remaining multiplication assignment, division assignment, modular division assignment, that is common. So how we are going to be perform this addition assignment, subtraction assignment, and by using that also we are going to be perform the same. So these are the assignment operators. These are the assignment operators. We'll see the examples for this. First, we'll go with the relational operators. What are the relational operators? We'll see. Relational operators used to write a condition. Result of these operators will be true or false. True in essence 1, false is 0. True is 1, false is 0. Relational operators are used to write a condition, to write conditions. Result of these operators will be true or false. Result of these operators will be true or false. What are the relational operators we have? We'll see that. Equals to, not equals to, less than, greater than, less than or equal to, greater than or equal to. So these are all the relational operators, which is used for checking the conditions, whether it is true or false. Whether it is true or false. Let's see the example for this. Example of relational operators. Let's suppose int a comma b. I'll be taking int a value. I'm giving as 10. B value 5, A equals to B. A equals to B. What it is going to give, we'll see. A equals to B. So here it is going to give false. Here it is going to give false. So next we have A not equal to B. Here also we are going to get true. Here we are getting true. Next, A less than B. A less than B. Here it is going to give false because A value is 10, B value is 5. False. A greater than B. So that is true. A less than or equal to B. So here also it is going to give false. A greater than or equal to B. True. We'll see the result of this. Yeah. A equal to B is false. A not equal to B is true. A less than B false. Greater than B true. A less than or equal to false. A less than or equal to true. Any doubt in this?
No, sir.
Next, logical operators we have. Logical operators used to combine more than one condition and will be getting the result of it. See, we have logical and logical or logical not. Logical and logical or logical not. See, returns true if both the conditions or operands are true, otherwise false. Both the conditions are true, the result will be true, otherwise the condition is false. The result of the logical AND will be false. So here returns true if any of the condition, if any of the condition or operand is true, otherwise false. In this case, only if we have both the conditions are false, the result will be false, otherwise it will be true. That is, if both the operands are false, then the result will be false, otherwise true. Both the conditions are true, true. One condition is true and the other one is false also, true. If both the conditions are false, then only it is going to be give false. See here, not of true is false and not of false will be, not of false will be true. We'll see the combination of that. X, Y, X logical and Y, X logical or Y, not of X is, we'll see. When we have two conditions, what will be the possible ways of writing uh, the truth values? We'll see first. False, 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 true, true, false, true, true. See here, logical and both are false. The result will be false. Both are false. The result will be false. False true will be false. True false will be false. True true will be true. Logical R will be, logical R will be first both are false. It will be false. Both are false. It will be false. If any one is true, also it is going to be get true. See here, here false, true, true false will be true again. Here it is true. Both are true, true. Not of x. X value we have here is, x value we have here is false. Not of x will be true. X value is false. Not of x will be true. X value is true, not of X will be false. X value is true, not of X will be false. So like this, we are going to be get this. If we want to see the example for these logical operators, we'll see that with the conditional statements. While we are discussing with the conditional statements, we'll see the example for these logical operators. Okay?
Sir,
Yeah.
sir, logical operator true becomes false, no, sir. Logical
Logical.
operator or
Huh. Both are false. Both are false. It is false. One false,
true,
one
sir.
true. It is true. True, true, true only.
In condition, you said false, sir.
Returns true. Returns true if any of the condition or operands is true. Any one condition, if true also, it will be true. Otherwise, false. That is, if both the operands are false, then the result will be false. Both the operands is false. So here, this is false. This is false. Because of that, the result will be false. Otherwise, it will be true. Sorry. Otherwise, it will be
Okay,
true
sir.
here. If any one condition is true also, the result will be true. If any
True,
one condition is false also, sorry,
true,
if any one condition is true, the result will be true. If both the conditions are
true.
false, then the result will be false. Is that clear?
Okay, sir. Okay, sir.
Yeah. Next, we have bitwise operators used to perform operations on bits. Used to perform operations on bits. Bits is nothing but zeros and ones. Bits is going to be perform operations on zeros and ones. Used to perform the operations on bits. See here, bitwise and bitwise or bitwise not, bitwise XOR, left shift, right shift. These are the bitwise operators. See here, condition result will be true false. We are going to be deal with true or false. The result with see the difference between logical operators and bitwise operators. If it is a logical operators, we are going to be check with the result of the conditions that will be either true or false. Obviously, true innocence 1, false innocence 0. But here we are going to be take the bits as zeros and ones and we are going to be solve that. We are going to be take the bits as zeros and ones and we are going to be solve that. See for that number, if you want to find out the bit operations, how we'll see that bitwise and if both the operands are both the operands are 1, then the result will be 1. If both the operands are 1, then the result will be 1. Otherwise, 0. If both the operands are, sorry, if any of the operand is 1, then the result will be 1. Otherwise, 0. Okay. Now here, if the value of if the value is 0, not of 0 is 1, and vice versa. Vice versa in a sense, that is, if the value is 1, not of 1 is 0. If C XOR is exclusive or or here both the operands are 0, the result will be 0. Both the operands are 1, the result will be 0. It means if both are same, the result will be 0. Otherwise, it will be 1. If both the operands are same, that is, both are 0, both are 1, the result will be 0. Otherwise, will be sorry. Otherwise, will be 1. Otherwise, will be 1. Next, we have left shift, right shift. Left shift, right shift. It will shift the number of bits towards it will shift the number of bits towards left, given number of bits towards left. Given number of bits towards left. It will shift, right shift operator will shift the given number of bits towards right. So this bitwise operators uh, examples how we are going to be uh, perform the bitwise operations. We'll see the examples in the next class. We'll see the examples in the next class. Now, we'll see the truth table, how it is going to be get for this. We have x is one operand, y is another operand, x bitwise and y, x or y, x, x or y, x or y. This is not x. Left shift, right shift, and all we'll discuss later with an example. So the possible combinations will be here 0, 0, 0, 1, 1, 0, 1, 1. See, both are 0, result will be 0. 0, 1, the result will be 0. 1, 0, the result will be 0. 1 and 1 is 1. 1 and 1 is 1. And now if you see here, 0 or 0 will be 0. 0 and 0 or 1 will be 1. 1 or 0 will be 1. 1 or 1 will be 1. X, x or y. 0 x or 0 is 0. 0 x or 1, 1. 1 x or 0 is 1. Now here, both are 1, 0. Not x will be similar. 0 is x value, not of x will be 1. 0 will be x, not of x will be 1. X is 1, not of x will be 0. Here also 0. So based on this, it will work. Example, we'll see that in the next class. So I'll show you how it is going to be work. And we'll finish the operators in the next class. And we'll start with the conditional statements, iteration statements, control statements.